What's good, Year 11s? Mr. Herman here, and this lesson is going to be looking at exercise 6b. We're going to be looking at how to determine the slope, or the steepness, or the gradient of a straight line when it is graphed, or when the graph has already been readily shown to you, or through two different points. Now, I am going to say that this is going to be a relatively longer video than usual because there's quite a lot of information to go through. So I'll try to be as quick as I can. But in also saying that, there are going to be quite a few features that I don't want you guys to miss out on. So it's a bit of a tricky balancing act, but we'll see how we go. So, one thing that makes a straight line when graphed that looks different to the other straight lines, there's quite a few things, but one of the most important things is the slope, or the steepness of this. This term has been given as gradient, and you can tell the word gradient, grad, also means gradual. Okay, how gradual does the steepness go? Is it not as steep? If we were to interpret it like a hill, is it very steep? Is it not steep at all? Is it flat? Which direction does it go in? There's all these different characteristics, okay? And these are characteristics that we can see here, okay? And we'll expand on each one of them as we go along. So straight line that rises from left to right. Now, this is a very, very important feature because a lot of students tend to get confused in regards to the direction. A straight line that rises from left to right is said to have a positive slope or positive rise. So with this example here, if we look from this point, because it is the starting point over here, and the end point, which is here, just for this little snippet example, from left to right, you can see that it is going higher across the page, so it's counted as a positive slope. As we go across to the right, we are going up. Okay? The straight line graph that falls from left to right, is said to have a negative slope, or negative rise. Now, this comment right here seems like a bit of a contradiction. Negative rise, that doesn't make sense. So we just think of it as negative slope. So from left to right, so from here to here, it is going down on the page. So every time we go right, we are going down. We always interpret it as going right. We never go left, so it's always going right. And from that point, are we going up or down? In this case, when we go right, we're going down to the line. So this is considered a negative slope or a negative gradient. When a line is a straight line, this is considered to have a zero slope. It's neither going up nor down. It's just a flat line. So in this case, the rise or the gradient actually has an amount, and it's zero. Okay, a rise is equal to zero. You're probably wondering, how do we get a number associated with these positive and negative slopes? We'll get to that working out in just a second. And when a slope is not defined from a straight line that is vertical, we can't give it a number. Okay, there are debates of whether this is considered as an infinity slope, which doesn't really make sense. So to make it easier, we just say that the slope is not defined. So whenever you get a vertical line in your question, you cannot define the slope. You cannot define the steepness. You can't necessarily walk up this hill with the gravity that we have right now. So think of it that way. It's not defined. So in order to determine the slope, instead of just talking about the general direction of the slope, we want to be able to give the slope a value, which is what I was talking about before. So first, we're going to select 2 points on the region, A and B. These points can be any 2 points, provided that they sit along the line. Okay. So as we go from point A to point B along the line, we move up by the distance. So from A to B, if we look at that, the up part, which is here, this is our rise, okay? This is the part that is going up, okay? We have to figure out what that distance is. okay, or how much it is going up by units, okay. So say for instance at this A point we have a digit here of 3 just for example's sake, and this B here is at 6. The up motion for this is just 3 because it's 6 minus 3, okay. And then across, this is going to be the run. So this run here, this is what's going across, okay. Across from point A to point B. And to get the slope, if we get our distance up as a number, we get our distance across as a number, our slope is determined by the rise divided by the run. Okay, this was an equation or a formula, sorry, that was made up by mathematicians. There are different ways of getting a characteristic number to a slope, but the best way is just get the rise and then divide it by the run. Okay, this right here is called a ratio. Anything that has to do with a division is considered as a ratio, and we've seen the ratio of how much up are we rising in regards to the run, and you'll start to see how different steepnesses, if that makes sense, will determine the number of a slope. As this line gets lower till it gets to a point where it gets flat, obviously that steepness is non-existent, and that's why the steepness is considered 0 in this previous example here. Okay, so if you're still feeling a little bit confused as to how this makes sense, all you got to know is we're just associating a numerical value to the steepness just to determine how we can determine what a steep line looks like and what a not as steep line looks like. We're just giving it a number, okay? So we're going to find the slope for this example. We're going to find the slope of a line that goes through the points 1, 4 and 4, 8, and we're going to find this slope in to 2 decimal places. The very first thing you got to do is I get into the practice of labeling these points, okay? So the first thing here, this is points 1 and 4, okay? You got to remember that this is the X and this is the Y, but I'm going to put it a little bit more terminology. Because we're dealing with 2 different points, I want to associate this with the first point. So I'm actually going to call this X1 and Y1 because we actually do have a pair of coordinates. This is going to be X1 and Y1, so obviously this is going to be X2 and Y2, but for now, let's look at X1 and Y1. 1, 4. So when X is equal to 1, which is right here, our Y value is going to equal 4, which is here. I'm going to put a point. So I'm still getting used to this this program of Photoshop using a tablet, which is quite annoying. There we go. All right. So our first point here is 1, 4. And then our second point is going to be 4, 8. And again, I'm going to label this as X and Y. But to be specific, it's going to be X2 and Y2 because it's our second point that we're talking about. So when X is equal to 4 for this coordinate, our Y value is going to equal 8, which is right here. There we go. And to just keep it consistent, we're going to draw a line that goes across these 2 points. Technically, this line goes on forever from end to end, but these are the 2 points that we know definitely sit on that line. Whoops, that was a terrible line. Let's try that again. Let's try one more time. Good enough. So we know that those 2 go on forever. Now, it's not necessarily the line that I care about. It's actually what this slope is. We want to give a number to this slope. Now, obviously, we know it's not 0 because it's not a flat slope. So let's see how much this rises. So our slope is going to equal our rise over run. How much does this rise by? 1, 2, 3, 4. So our rise in this case is 4. And what's the run? How much does it go across from point to point? this is going to be, now be careful because you can't consider each of these blocks as a number. You've got to make sure that you're paying attention to how much is going across here. So this is 1, 2, 3. So a run is 3. So 4/3 is our gradient, but it's asking for this into 2 decimal places. So what you will do is you convert this. You can use a scientific calculator to convert this to a decimal, or you can just put in 4 divided by 3 in your calculator and make sure it shows it in decimal form. And what this should equal, I'm putting an approximate equals here because we know we have to round. This is going to be 1.33. Okay, so our slope is 1.33. All this is saying, this number here, all this is saying is that for every step that I go across by 1, I'm going up by 1.33 units. So I go across 1, I go up 1.33. That's all that number means. That's what that slope means, okay? Obviously, the higher this number is, the steeper the slope will be. The lower this number is, but not to 0, the less steep this line will be, okay? That's what that means. So, we're gonna look at the second example. Now, before we get to the next examples, there is a formula that we can use, and it's just an extension of the x1, y1, which is what I was talking about before. So another way of using the rise run method is to use this formula, and you will need to use this formula in further maths, okay, because you will see it pop up quite a bit. And all this is just showing you that in order to get the rise and the run, let's just give again these points A and B, okay? And we know that point A is going to have an x1 and a y1 associated with it. This is just a coordinate, okay? And all that 1 means is we're talking about our first point, okay? And then B, x2 and y2, again, we're just talking about the second point. That's where the 2 comes from, okay? Because I can't just say A is going to have an x and a y and B is going to have an x and a y, because we have to be a bit more specific. We have to say which points we're specifically talking about. Okay, that's where the 1s and the 2s come from. All it is at the end of the day is specific terminology for the point A for 1 and for the point B for 2. The actual slope is determined by, again, rise over run. But this rise, to get this rise, all we were doing is just finding the difference between the first y coordinate and the second y coordinate. How high does this go up? So if this was 6 and this was 3, as I was saying before, to get the difference, or to get that rise, we just do 6 minus 3. If this was 4 and this was 8, it would be 8 minus 4. If it was 1, 9. 9 minus 1 will be 8. So in general terms, we have a y2, which is the y coordinate, the second y coordinate, take away the first y coordinate. This will tell you how high up, or the rise, will be in this case, okay? This is just in general terms. When you get the question, you'll be given your y2 and your y1, and all you would do is just simply substitute it into the rise formula to get the difference. Same thing with the run. We're trying to figure out how much this goes across from left to right, and you just get your x2, which is right here from your second point, and you subtract x1, because we're getting that difference that goes across here. And with this in mind, instead of rise over run, it's just y2 minus y1 all over x2 minus x1. Right? This equation right here might seem pretty confusing, but all it's saying is that, look, if you give me a y2 and a y1 and an x2 and an x1, I can simply substitute it into here, and I can tell you what the slope of this, or the steepness of this line is. Again, we'll dive into the deep end. I don't think it's deep end, I think it's pretty shallow, to be honest. It's 6b, and we'll have a look at how to determine the slope given these 2 points here. So find the slope of the line that goes to the points 0, 10, and 4, 2. Okay, 0, 10. So when x is equal to 0, y is equal to 10. So when x is equal to 0, which is here, our y value is going to equal 10. So we're on the actual y-axis. So this right here is our x1, comma, y1. I'm just going to put a line just in the middle there to show that the next one is going to be x2, y2, 4, 2. So when x is equal to 4, here, y is equal to 2, which is that point there. So that there is x2, comma, y2. So now, when we figure out what the slope is, again, our slope, but this time we're going to use that different formula. It's going to be y2 minus y1 all over x2 minus x1. And we know what our y2 and y1 is, and we know what our x2 and x1 is. We've given these labels already here. And I know some of you are going to be asking a certain question. I'll get to it in for a second, but before I substitute these values in, I want to see these 2 points here. I'm going to draw that line. Shocking. Try that again. I'm sure in time I'll figure out how to do straight lines using this program. For now, I'm just going to draw it. But what are the main characteristics from this is, from left to right, this is going downhill. Okay, from left to right, every time we go to the right, it is going down. So our slope, we are going to expect a negative slope, and therefore we're going to expect a negative answer. If you do not get a negative answer, you've done something wrong within your calculations. So our y2 in this case is a 2. So we're just going to do a simple substitution. And our y1 is a 10. This is all going to be over x2, which is 4, minus x1, which is 0. All I did was just a straightforward substitution. That was it. Now I can figure out these values. 2 minus 10, sorry, is negative 8. And 4 minus 0 is equal to 4. When you simplify this, this will give you the answer of negative 2. So our slope in this case, yes, it is a negative, and it's negative 2. All that means is for every step that we go across 1, we are going down 2 units. Okay, so we go across 1, we go down 2 units. Every time we go across 1, we go down 2 units. Now this is a shocking line representation if you were to rule this, but you can see every time we go across 1, we go down 2. Again, that's what that slope means. Okay. Last example here. Find the slope of a line that passes through 1, 7 and 4, 2. Label x1, y1. Now, some students will say, sir, when we do this, what happens if I accidentally label this one x2, y2 and this one x1, y1 and I put that into the formula here? Well, that actually won't make a difference. Assuming that you do the calculations correctly, because you might run into double negatives, you actually will get the same answer. And I'm going to show you what will happen is if we flip these two around. I'm going to show you the first x1, y1, x2, y2, and I'm going to flip it around labeling wise. And you can see that you will get the same answer. So our first point x1, y1 is 1, 7. When x is equal to 1, y is equal to 7, which is this point here. And when x is equal to 4, y is equal to 2, which is this point. Get our line. It goes down there. Hey, a bit better. This technically goes on forever from both directions. It's a negative slope from left to right, so we're expecting a negative number. And we're going to write our slope is equal to y2 minus y1 all over x2 minus x1. We know what our y2 is, it's 2. We know what our y1 is, it's 7. We know what our x2 is, it's 4, and we know what our x1 is, it's 1. Work this out. 2 minus 7 is negative 5. 4 minus 1 is 3. Now it is asking for 2 decimal points, so I'll just put an arrow up here. Again, we know that our answer is going to be negative, and this solution is going to be negative 1.67. Calculator will say negative 1.66666 because it's asking for 2 decimal places. It's negative 1.67. That should be an approximate equals because we're doing rounding. All right, let's look at a scenario now where we change this labels and we call this one x2 y2 and this one x1 y1. So I'll put those numbers up the top here. So we've got 1, 7, and we've also got 4 and 2. And in this case, this here is going to be our x2 y2 and this here is going to be our x1 y1. So in this scenario here, I've labeled them differently. I've made sure that it's x, y, x, y, not x, x, and y, y. If you do it as x1, x2, and y1, y2, that is incorrect. Okay, but in this case, we're just swapping the this coordinate here to be our second term and this coordinate here to be our first term. So we'll write our formula as our slope is equal to the slope formula should still be the same, y2 minus y1 over x2 over x1. Alright, this time our new y2 is 7, our new y1 is 2, our x2 is 1 here, and our x1 is 4. And the difference that you'll see, 7 minus 2 is 5. 1 minus 4 is negative 3. Hey, this looks exactly like this one here, but the negative has been flipped around. A positive divided by a negative will give you a negative answer. A negative divided by a positive answer will give you a negative answer. So regardless, our answer is gonna be an approximate, and it's still going to be negative 1.67, which is the same answer that we got here. So if you flip these numbers around, regardless of what type of question you get, if it's a negative slope or a positive slope, you will still, assuming you get the arithmetic correct, you will still get the same slope. Okay, just don't get into the habit of labeling this one here, x1, x2, and y1, y2. That right there is incorrect. I've seen students do that before. Don't do it in that way. You're always going to get an x and always going to get a y. You'll just either give it a number 2 or 1, regardless of what position that it's in. This concludes exercise 6b. Sorry that it is a long video, but it is quite a lot of information to get through to you guys. One little note that I will tell you guys, that when you do these questions, be careful. You might stumble across questions where some of the coordinates that are given to you may have a negative number, like this. So you might get 2 points that look like that. Okay. When you substitute these values in, make sure that if you see 2 negatives put together like that, so it's y2 take away and then a negative number, those 2 negatives turn into a positive. Okay, be very, very careful for that, because you might get an incorrect solution based on your working with negatives. Okay, other than that, go ahead and check the log sheet for exercise 6b and do those questions. This will be due by the end of next week, Friday. So I'm recording this now on the 17th. So next week on Friday, on the 24th, this will be due. So you got quite a bit to get this done. But I'm going to post this up early for you guys. Alright guys, take care. Wash your hands. Sneeze into your elbow. Don't go outside. I'll see you in the next video.